Final thing. So they're still balancing redox equations, but now it's gone up a wee level. So this is as hard as I'll get. These few here. So start as normal. Oxidation number of iron 2 is +2. Chlorine there is 2 times 0, +3, and -1. Now identify what's oxidized and what's reduced. Iron's gone from +2 to +3. Loses 1 electron. Therefore oxidized. Therefore the reducing agent, which is Fe2+. Chlorine on the other hand goes from 0 to -1. It's reduced, it's reduction. Reduction is gains. Gains 1 electron, therefore reduced, therefore oxidizing agent. Run tight in space. You can write that later. That's not the problem. Now it's going to get a wee bit more difficult, but just keep in mind your definition of an oxidation number. The charge that an atom appears to have when electrons are distributed according to certain rules. Charge at an atom, that's the big thing. Charge at an atom. So, how do we convert this English into maths? Iron loses 1 electron, so Fe minus 1 electron gives you iron, just these individual atoms, while chlorine gains 1 electron. Lovely, we'll cancel them out, won't we? No, because the problem here is that it's a chlorine molecule. So your Fe is good, Fe and Fe. So that chlorine molecule is Cl2. If one chlorine atom gains 1 electron, a Cl2 molecule will gain 2 electrons. Now it's not Cl2 over here, but to keep it balanced, you stick a 2Cl. And then your original iron here, and now you do your sum equations. So multiply that bottom line by 2. And 2 Fe, still in chat yet. Same number of electrons, different sign. And you have her. And I can just, since there's no spectator ions or no other atoms here, I may as well just fill it in down the bottom. And that's the balanced equation. You have a 2 in front of your iron, 2 in front of the Cl, and a 2 in front of that Fe. I forgot to write it down. Is that good? Right. Next one here. Similar job, I'll just turn down the radio a wee bit. Now, work with your oxidation numbers here. So oxygen, 7 times -2, you're at -14. You got to go to -2, so -14 to -2, you're adding on 12. So 2 times +6, +2, +1, +3, +3, 2 times +1, -2. Match them up. Generally, it'll not be your hydrogens or your oxygens. +6 to +3, it's a reduction. So gains 3 electrons, therefore reduced, therefore oxidizing agent, which is Cr2O7 minus. Iron then, lovely ability to get oxidized, loses 1 electron, therefore oxidized, therefore reducing agent, which is Fe2+. Now, change that English into maths. So iron loses 1 electron, Fe minus 1 electron gives you an iron, and work with atoms first. Chromium, ignore that Cr2, deal with that the next time. Charge that an atom appears to have. Chromium gains 3 electrons to give you chromium. Problem here is it's Cr2, so your iron is good. So if 1 chromium atom gains 3 electrons, 2 chromium atoms is going to gain 6. Is it Cr2 over here? No. So you just stick a big 2 in front of it. Now to balance those, your simultaneous equations, multiply that top line by 6. So 6 Fe minus 6 electrons to give you 6 Fe. You don't need to do anything here. Same number of electrons, different sign, there you go. And now you've got 6 Fe plus Cr2, 6 Fe plus 2 Cr. Horsing them. Numbers in front of the compounds or whatever. 6 Fe, Cr2 is good, 6 Fe, 2 Cr. And then the last thing, visually inspect, which can be tough. So 7 oxygens here on the left hand side. To get the same number on the right hand side, throw a big 7 there. And now you've got 14 hydrogens. And then just stick a 14 there. That worked out handy enough. So your balanced equation, Cr2, so 1, 6, 14, to 2, to 6, to 7. So don't be scared to try these yourself. No good just watching them. And then the last one here. Well, might have one more. MnO4 minus. This is actually no real different, I don't think. This isn't your atoms or your molecules. Should have done that first. I'll ignore that one. I'll get on to this one. And this will be, because it's N and N2. So fill in your oxidation numbers here. 3 times minus 2, minus 6 to minus 1. Adding on 5, plus 1, plus 2. 4 times plus 1 is your hydrogen. 2 times minus 2. 4 minus 4 is 0. Yeah. Match them up. Zinc, 0 to plus 2. Loses 2 electrons. Therefore oxidized, thinking of our oil rig. Oxidation is loss of electrons, therefore reducing agent. And your reducing agent is Zn. Going with your nitrogen here, yeah, there's a change. Plus 5 to plus, or minus 2, sorry. That is gaining 7 electrons, which is a redox reaction. One loses, one gains. Therefore reduced. Therefore oxidizing agent, which is NO3 minus. Now change that English into maths. Start with the easier one. Zinc loses 2 electrons. Minus 2 electrons gives you zinc, and work with atoms first of all. Nitrogen gains 7 electrons to give you nitrogen. Then deal with the problem here. The N2. So your zinc's all okay, individual atoms. That's just remember your charge on it. So Zn minus 2 electrons gives you Zn. Whereas now your nitrogen is an N2. So if one nitrogen gains 7 electrons, 2 nitrogens, which is going to be over here, will gain 14. And we'll have to, it's not N2 here, you stick an 2 in front of it. And now solve those sim equations. How are you going to solve them? Multiplying that top line by 7. 7Zn. And then throw these numbers in front of it. 7, 7, 2, and nothing. And then the last thing, visually inspect. So 6 oxygens here. You've only got 1 here, so a big dirty 6 in front of it. And then you've got 12 hydrogens, 16 hydrogens there. 16 in front of that. And keep your examiner happy. And if you can do all of these questions that we've done with you, then you're flying. You're absolutely flying. Some of them, as I say, might be a half an electron here. You know, just work with it. It's a simultaneous equation. There's one there like S2O3 and S4O6. That's an example where you're going to be losing half electrons.
All right.